right? So they tell us that we've got this, and just be careful because all of your numbers are going to be slightly different. So I'm just using one student's numbers, right? We've got 55.9 grams of water, and that water was at 99.21 degrees Celsius. And we drop a block of aluminum or zinc into it, and the water goes down to 96.9 degrees Celsius. Right. On the other half, we've got 23.9 grams of zinc, and that zinc started off at 21.1 degrees Celsius. And they want to know the heat capacity, right, the specific heat of the zinc. So we have to do Q equals MC delta T twice here. Once for the water, right? We find that energy that the water lost, and that's going to help us find the energy that the zinc gained, right? So Q for the water first, right? We've got 55.9 grams of water. The specific heat of water is 4.184 joules grams degrees Celsius. And my temperature change for the water, temperature change is always final minus initial. So final is 96.9 minus initial is 99. We get a negative 2.31 degrees Celsius. So heat for the water, multiply that all together, right? The water loses 540.28 joules. All right, now we want to find information for zinc, right? Q equals M C delta T for the zinc. What is our Q for the zinc? Yeah. Yeah, right. The water lost 540 joules, so the zinc's going to gain 540.28 joules. So, all right, we can set up Q equals MC delta T. 540.28 joules equals my mass, 23.9 grams of zinc. I'm looking for the specific heat. And then to get delta T, we need our final temperature. What is the final temperature of our zinc? That's our initial temperature, 21.1. Yeah. Exactly, right? The water stops, it drops down to 96.9. That means the zinc gets raised all the way up to 96.9 because that's our thermal equilibrium between those two samples, right? So our delta T is like 75.8 degrees Celsius, right? So 75.8 degrees Celsius, divide that across, and I get a specific heat of zinc of like 0.298 joules per gram times degrees Celsius for that one. Again, your numbers might be a little bit different. Your mass might be a little bit different. Your temperature change might be a little bit different, but the steps are going to be the same. We want to find the heat that the water lost first, and then we use that information to say, okay, this is a closed system, so I can't have any heat lost. So if water loses this heat, it's because zinc gained that same amount of heat. I plug that in. They give us the mass. The next jump we had to make was realizing that even though they didn't tell us the final temperature of the zinc, it had to be the final temperature of the water because they're in the same system together. So that got us our delta T, and we could just rearrange that to solve for our specific heat of the zinc. Yeah.
Question 6 on